Under normal conditions, a certain bacteria population doubles every 4 hours. A bacteria colony begins with 500 bacteria. How many bacteria are in the population after 11 hours? For our exponential growth model, since we know the doubling time, we can use the model P of t equals P naught times 2 to the t over d. So P naught is the initial size of the population, which in this case is the 500, times 2 to the t over, and then d is the doubling time, which is 4 hours, so 4. So this is our formula for P of t. And now we'd like to know how many bacteria are in the population after 11 hours. So that's P of 11. So we have 500 times 2 to the 11 over 4. So now we can plug this into our calculator. 500 times 2 raised to the 11 over 4. And it looks like I missed 11 over 4. There we go. Okay, and we're going to go and round this to the nearest whole number because we're talking about how many bacteria there are. And so it only makes sense to talk about a whole number here. So round to the nearest whole number, that's 3,364. For part B, how long will it take for the bacteria count to reach 10,000? We just take this formula that we have, and we want the output to be 10,000. So we have 10,000 equals 500 times 2 to the t over 4. And now we're trying to solve for t. We can divide both sides by 500. So 10,000 over 500 is 20. And then here the 500s cancel. We have 2 to the t over 4. Then we can take the logarithm of both sides to get this exponent out of an exponent. So I'm going to do the natural log because I'm going to end up using my calculator to approximate anyway, and my calculator has a natural log button. So I do the natural log of both sides, and then I have the logarithm law that tells me that this exponent can come out in front. And so now I have natural log of 20 equals t over 4 times the natural log of 2. So now to solve for t, I can multiply both sides by 4. So 4 natural log of 20 equals t times the natural log of 2. And then divide both sides by the natural log of 2. Okay. And so that's going to give us t is 4 natural log of 20 divided by the natural log of 2. And so now this is what I need to plug into my calculator. So I've got 4 natural log of 20 divided by the natural log of 2. And so this is measured in hours, and I'm just going to round to the nearest tenth here. So 17.3 hours. So approximately 17.3 hours.